Good afternoon. I hope you all enjoyed lunch today. Am I clear? Can you hear me in the back? Awesome. All right, so I'm here today to talk to you a little bit about smoke testing your Hadoop cluster. And I will go into what that means throughout the presentation. A little bit about the agenda. We're going to talk a little bit briefly about who I am, describe what is a smoke test, when you should perform those smoke tests, why you should do that, and then how to do that, providing actual examples of command line execution of these smoke tests. So I am what they call a principal systems engineer. I like to say consultant. I help people fix problems. I'm into automation of systems. I like to teach the computer how to do my job over and over again instead of me having to sit there and hit the same buttons. I've been doing this a few decades and got into the Hadoop industry, so to say, about 9 years ago. I always like to just describe it as, I remember when CDH2 came out, so it was a little while ago. Back then, we were hand-editing XML files and using rsync to push them out to the cluster. Cloudera Manager and Embari didn't exist. Kerberos, no. So I've been doing it for just a little bit. Now, what is a smoke test? It's a very quick test. It actually came from the realm of hardware testing, where somebody would create an electronic item, and you want to test it before you ship it out to somebody, so you would plug it into the power mains and see what happened. If it started sparking, you kind of put it in the bin to be recycled and went to the next item. Very similar concept here with software. You want to do a very quick discovery to see if the program you just created has some basic functionality. You address basic questions of, does the program run? If you have a GUI, does the user interface open? Can you click on that big button in there and does something happen? Whether or not it's correct or not, just enough of it to say, hey, we've got basic functionality. In our case, we're going to look at, can we read and write to HDFS? Can we run a Mapreduce job? Just a short one. The whole aim of this is to make sure that you don't have some complete horrible failure that you're about to turn over to your clients and say, yeah, my cluster's okay, go ahead and start running your jobs. You want to kind of make sure that that's happening before you go and embarrass yourself, which I've done before. Now, in the realm of testing, I'm definitely no expert in this, but I did a lot of research for this talk. I went and talked to my local software QA people, and they kind of taught me a little bit of things. There are several levels of software testing. You have your unit testing, which is basically individual components of your code. For example, a function. Does this function that's supposed to sum two numbers, if I give it a 1 and a 2, do I get a result of 3? That's basic unit testing. Then there is integration testing, where you take that function and another function in your program and see if they work together. One function would be receiving data off the network. Can it pass it to that summation function, then take the result, pass it back on the network? So you take multiple units of functions. Then you have your system testing. That's where you have your entire program, reading, writing to the network, doing your sum function, and everything else that it's supposed to do, and you test out that entire system. And lastly, you have your acceptance testing. This is where you get your end users involved, and you ask the business, does this program we created for you meet the needs that you hired us to create that program for? So those are the levels. Within those levels, there are different types of tests. So for unit testing, you can do your smoke test, which is your quick, does it run, can it compile and execute? Then there's your functional test. Make sure that your tests of that software function, does it provide the correct output? We give it 1 and 2, get 3. If we give it -5 and the square root of 4, does it give us the correct results? It's more thorough and involved. Next, we have the usability testing. That's where the end user would go in and see, for example, you're creating a web UI for an order input process. This is where you bring your users in and you say, okay, input the data into the order form, and now we want to print it. Now, is printing an involved process where you have to pull down the menu, go to a sub-menu, click something, a dialog opens, and then you have to choose a bunch of things, or is there just a big button that says print and you get an output? That would be usability testing of a piece of software. There's security testing. Security teams go and look at vulnerabilities, buffer overflows, that sort of thing. Performance testing, most people know about load testing. If we have 100 people doing this order input form, what happens? Does the system fall over? Do we need to add more machines? What happens in those various situations? Then we have regression testing. There was a bug in the program. We fixed it. Some more bugs. We fixed them. But in fixing the second set of bugs, did we unfix the first? So we test for regressions in the code. Lastly, there's compliance testing. Your organization or possibly external organizations, the government may have standards that your program has to follow. Standards, for example, PCI DSS, if you're dealing with credit cards. You have to have certain ways of doing things, of securing your data. Does the program that you wrote follow that compliance testing? Now, that was a lot of things about testing. Honestly, myself, I didn't know a lot about that before. I just called everything a smoke test. Here, run this. Does it pass? OK. What that results in is that I'm actually talking about an integration smoke test. We were seeing about the integration of your Hadoop components within each other. How does Hive interact with your HDFS, Yarn, et cetera? When should you perform these smoke tests? Well, basically, most any time you make changes to your system. Anytime you do a new install of the cluster, it's a good time to do a smoke test. Did the installation actually work? Now, I know Cloudera Manager and Embari, we have nice UIs there, and they'll do some testing themselves. But depending upon the versions, and there's been a lot of releases over the years, sometimes it tests things, sometimes it doesn't. It might take 10 minutes to do certain tests. You kind of want to do something quick, a little bit more quickly than that. I even suggest after doing installs or upgrades that you also consider doing smoke tests after even doing a configuration change. You may be doing a rolling restart, but you still want to check and make sure, did that actually work? We might still be live in production and rolling on, but it's better to have an understanding that something's not working before your customers start calling. Especially when you're inside of a maintenance window, assuming your organization is doing change control, et cetera, you kind of have a little bit more leeway in being able to fix things before people start yelling at you that the service is down. So why do this integration smoke testing? Again, catch things before other people tell you. It kind of helps with your impression amongst your coworkers in your company. Especially with your customers. And it also can basically mitigate your risk of outage. If you catch things soon enough, you'll be able to hopefully fix them soon enough, or at least roll back whatever you were trying to accomplish. Now, there's one thing that the integration smoke testing I'm talking about does not do. It's not meant to do specifically. It does not catch any problems that might occur within the applications running on your Hadoop cluster. Your organization is probably going to have Mapreduce Spark jobs. You've got data flowing in, it's processing, and results are accumulated in reports, et cetera. These integration smoke tests don't cover that. There's actually something called a system test that would cover the entire system as a whole, including all of that stuff. And assuming that your sysadmin team does or does not include working with the data. You may have external teams that do data analyses. They may be responsible for or know best how to do the overall system tests to make sure their parts are running. So I do have a few examples of how to do a lot of these. The examples I'm going to show are for a non-secured, unencrypted environment. You would do things a little bit differently when your cluster is Kerberized or you're using TLS. Sometimes the port numbers change. A lot of these examples I'll be showing are Cloudera specific. We do have similar ones for Hortonworks environments. It's just a matter of where some of the example software is stored that comes with the distribution. And they also assume that you're sitting in an SSH session on your edge node as a regular user. You don't need to be root for any of this or have any privileged access to the cluster. Don't worry about snapping pictures or taking too many notes on this. I've got links at the end. All this code is available, so you'll be able to pull this down and use it yourselves. First off, we have Zookeeper. The first thing we're going to do here is set an environment variable that lists the machines that are running Zookeeper in your cluster. If you have a single one, you just replace localhost here with the name of that machine. If you have 3 machines in your ensemble, you would just comma separate them. So host 1, colon 2181, comma, host 2, colon 2181, comma, et cetera. And we set this variable just to make things simpler here. We also will use this particular variable further on in some of the tests. So each test kind of builds upon the others. The actual code here is that we are going to use the Zookeeper client. This is a little bit complex here. And you cannot see my pointer very clearly in that. So we're basically going to push a bunch of data, a bunch of commands into the Zookeeper client, look at the results. First thing we're going to do is create a Z node called zk_test. And we're going to give a value of my_data. We're going to list the root of your Zookeeper install, and you should see zk_test in that output. We're going to retrieve that Z node. It should give you the value of my data. We're going to set a new value on there with the data value of junk. We're going to get it again and see that junk is the output, and then exit. Quick, easy, hands-off. You just cut and paste this whole thing, and you should get a visual indication of if things are functioning or not. HDFS. Let's list the root of the file system. Do we get something back? Let's put a file. Every machine, Linux machine has etc host. We'll just write it out there into temp on HDFS. We'll retrieve it back, and then we'll cat it just to confirm that it actually is the one that we put there. Reads, writes, etc. Mapreduce. Most of the distributions come with the Hadoop examples jar. There's a few programs built into that, one of them being the pi estimator. We're just going to run it with some small values. Should take about 30 seconds to get out, execute on your cluster, and come back with the value of pi to 6 or 8 digits. This way you are exercising yarn, you're confirming your Mapreduce code, libraries are in place, et cetera. In addition, there's a word count example. We're going to create a file on the local system. It's going to have a string of values. This is the end, the only end, my friend. Push that out to HDFS, run the word count on that, and then cat the output from HDFS. You should get each word summarized with a value of how many times it appears. Spark, same exact concept. There's a Spark Pi example that comes with the distribution. We're going to run it in yarn mode on the cluster instead of in local client mode. You should get the value of pi out. Additionally, Spark has a word count program, or rather, we've created one. I couldn't locate an actual examples that comes with the distribution. We're going to do the same thing as Mapreduce, create a file, push it out to HDFS. And then in our Spark shell, we're going to do a little bit of word count code. Some of this is wrapped here on the screen, just because of the way formatting worked out. But if you cut the whole thing, paste it into your terminal, eventually you'd get an output similar to your Mapreduce. Everyone seems to forget about pig. I don't know why. But it comes installed with most distributions, and so we've got a little bit of code that can test that out. We're going to push the etc password file into HDFS, and then run some pig code that goes and looks at, since the password file is colon separated, we're just going to pull out the first column. So that's using pig storage by each colon. We're going to generate the output, put it into a file in HDFS, and then cat that to screen. You should just get the first column of whatever was in your password file. Next is Hive. You need to know where your Hive server is, put that into a variable. Then we're going to use beeline to create a table. Now, you are using beeline, right, and not the Hive command line? Okay. This is the command output. We're going to create a table, the most simplest. We've got an ID column and a name column. And then we're going to insert some values into that table. Value 1, Justin, number 2, Michael, number 3, Scott. And then we're going to do a select star where ID equals 1. You should get the return value of Justin out of that. That proves that your Hive metastore is functioning. Everything is working in its infrastructure. Now with Impala can read data that you write in Hive. So let's go ahead and query that same exact table we just created. But first off, you need to tell Impala that that table exists because it doesn't know that what you just did in Hive. So we're going to invalidate metadata, and in the same Impala shell, we're going to just select star from test Hive just to have a little bit different results returned. And of course, you need to set a variable as to where one of your Impala daemons is. If you're using an Impala load balancer, feel free to push that value there instead. Now, Impala can also create its own tables, so we're going to do something very similar to Hive, but using Impala. We'll use the Impala shell, create a table called test Impala, ID column, name column. We'll put in some values, Bohin, Shanlin, and Xiaobing, and then select star from that table. ID is equal to 1, and you should get a result back, the first value you put in. Additionally, we've got Kudu, and usually the best way to query Kudu is via Impala. There's also the capability to use Spark to talk to Impala, read and write. Unfortunately, the Spark code I've been working on will fit into about 6 of these slides, so I couldn't quite summarize it here for you. But we've got it on our website. Checking Kudu is very much similar to how we did just straight Impala into Hive. With the added part, when you create the table, test Kudu, you need to set partitions. So partition by hash ID. We're going to set partitions to number of 3. And stored as Kudu is the key part when dealing with this, because otherwise it's going to write to HDFS instead of Kudu. Inserting data will be very simple. We'll insert Wasim, Nanad, and Mohsin, and then query that back pretty much the same as the others. Where ID equals 1, you'll get back Wasim. Hbase. This is a simple here doc. We're going to create a file that has the commands we're going to run, and then at the end, Hbase shell reference that file, and it'll run those the execution. We're going to create a table called test with a column family. We're going to list test, so we should see the definition there that's in Hbase. We're going to put a row in there, test, row 1, column family A, value equals 1, a value of 1. And then we're going to scan that test table. We should get that row that we just put in there back. Exit the shell. Very simple. Accumulo. If anyone's ever used Accumulo before, I myself have not. It's pretty similar to Hbase. We're going to create a table, insert a row, flush that out into make sure that it goes to permanent storage, and then scan that test table back in to see that row 1 that we added. We have Solar out there, so we'll set a variable which point at one of your solar servers. This one's a little more complex. We've got 2 slides worth of details here. We're going to use solar control to generate a local config directory. We'll throw it in temp because this isn't something we need to keep around. Then we're going to create an instance of t_conf based upon that configuration. We don't need to modify the configuration. We'll take all the defaults out of it. This is just a quick test of it. Then we're going to create a collection called test_collection t_call. There'll be just one replica, and we'll use the configuration of tconf that we uploaded in the previous command. The interesting part is, at least in CDH, we've got a set of examples that come with the code. So we're going to change into that directory. We're going to use the jar that comes with it to upload a bunch of XML files into the Solar environment. And then we're going to use the curl command line to query that particular slice, and we'll get back a bunch of results from that output. We should see something about Apple iOS devices, maybe a Dell laptop, basically some of the bits that were uploaded for the test. Lastly, we have Kafka. We'll test that out by setting a value as to where one of your Kafka brokers is located. I've got a variable here called zk_root. And for the most part, people will tend to leave this empty. But in Zookeeper, or I'm sorry, in Kafka, there's a way of putting the bits that are going to go into Zookeeper into a subdirectory, if that's something that you might be into. I started doing that when I first started deploying Kafka, just figuring, why pollute the root of my Zookeeper environment? Let's put it in a subdirectory. So I give that option here to do that. We're going to create a topic in Kafka, pointing at the Zookeeper environment for that set of brokers. We're going to call it test Kafka, set 1 partition, and replication factor of 1. I just assume there might only be 1 broker. Maybe you've got more. Feel free to increase those values. Then we're going to list those topics, make sure that we have our test topic in that output. Next, we're going to get a little complicated. We're going to open up another shell, because we'll need 2 shells for this example. In one of the shells, we're going to start the Kafka Consumer, and it's going to be reading from the test topic. You won't get any output here yet. In the next shell, we're going to cat the etc password file into the console producer, and over here in our consumer, you should get that password file out within a moment or 2. Now your consumers and producers are working through your Kafka environment. So we've gone out and created all this stuff in your live production environment. Well, you should make sure to clean that up. I don't have the example code here exactly, but feel free to check out our GitHub environment. It's got the few commands you'll need to go ahead and delete those tables, remove all those test files that you just put out there, and clean things up. That way, when you go through your next smoke test, in your next software upgrade or configuration change, you won't get an error. Table already exists. This way, you can fully test out everything, including your deletion. Questions? Yes, sir. So why have all this when Hortonworks, Embari, and Cloudera Manager tends to do a lot of this? Over the years, the tools have not done all of this. And so depending upon which version of the Cloudera Manager or Embari you have, you may not have all of this functionality. Some of the testing also takes several minutes after you bring up your services to go out and do these tests. For myself, I like to basically check to make sure that my monitoring and management system is also doing its job. And I get feedback from these smoke tests a lot quicker than waiting 5 minutes for Cloudera Manager to do its periodic check. So it's kind of a... These should take about 5 minutes to run, all of them. They're very quick and designed to be very, very shallow in what they test. So even with 500 nodes, you might only be using 4 or 5 of them for some of these. Correct. So you might have to customize some of this for your environment. These are just very basic vanilla cluster installs. So feel free to tweak a little bit of the values to your environment. Yes, sir. Correct. We've been working on the Hortonworks versions of these as well. So they will be very similar. Some paths will be different. I don't have the Hortonworks specific things like Phoenix or a Ranger examples quite yet. So I'm still working on building a lot of this stuff out. If you have those, it's a GitHub repository, so feel free to send a pull request. We'll happily add it to the repository of examples. So sometimes for me, it's hard to know what Cloudera Manager is testing. Is it actually doing these Zookeeper tests? Or I know they do a lot of canary tests of, write a value and whatnot. From my perspective, I'm not sure exactly what those are. There might be a document on their website describing them. Here, I have it well documented out. Here's a process to run really quickly, and that way I'm positive as to what did or did not work. Specific way to test the name node. There are various load tests that I know of that can test the name node, but they're very intense and involved. At best, I could see checking to see whether the ports are up, but these are meant to test more of the entire system of HDFS. The name node is included in that where I write a file and read. So overall, it does get tested, but not every single aspect is meant to be tested with these smoke tests. That might be more of an integration functional test, go through and see, can I do an RPC? Can I do all these various things that HDFS and specifically the name node does if you want to create that sort of a test environment.